Hi there, welcome back here, guys. In this lecture, we have talked about the differences between a private and internal. In this lecture, we'll take a look at the storage. So how are data persisted in the storage, how we are storing the data, and how we can access them. This lecture will be AI lecture. It will be quite extensive. If you feel like you have enough information about the storage, you can skip to the next one. Okay, so let's start. Let's start very simple. Let's create here a new contract. So in a contracts folder, a new file, let's call it storage.sol. We'll go into faucet contract. Let's copy the header, so contract and the pragma and license. Let's paste it here and just simply rename the contract for storage. All right, and let's create here a couple of state variables. There is reasoning behind these variables. I will be explaining very shortly. Okay, but first let's write them. Let's create here a uint of 8 bits, so 1 byte, and we will be calling it will be public, and we'll call it A. We'll assign here value 7. Okay, let's continue with uint 16, so 2 bytes, public B. Let's assign here number 10. Now let's continue with the address. So address type, all right, public C, and let's get here some address. Address has 20 bytes, by the way, and let's copy address from Ganache. Ganache, let's copy this first address here. All right, and let's get it here, semicolon. Now let's get here bool, so let's write here bool abcd, and this will be, let's say, true. Okay, now some uint, let's say 64, so 8 bytes, and let's call a little bit public, and let's call it abcde, and this will be value, let's say 15, let's say, okay, 15. Okay, so abcde, and I will create some bigger values, let's say uint of 256, so 32 bytes, public f, let's assign here value 200. Now uint 8 bits, some small value, and public abcdef g, and the value will be here 4d k, and the last one, again big one, uint 256, public and h, and let's assign here value 789. So just there some random values, and you will see how storage is allocated. Okay, and now you can save this, and I will show you how you can imagine how storage looks like. So I will go to my drawing tool, and here it is. Okay, so you can imagine storage as an byte array. Okay, so array of some items containing bytes. So each item in the array is also called, you can call it slot. Okay, so each item in the array is also marked as a slot. And in total, you can imagine you have the number of these slots is a 2 on 256 minus 1. So that's the total number of all of the slots you can have allocated in the storage. So that's quite a lot. That's quite a lot. That should be enough for you. Okay, so 2 at the power of 256 minus 1. Okay, so each slot has a dedicated number. So for example, this can be the first item, slot 0. The second one will be slot 1, slot 2, until the last one on a 2 on the power 256 minus 1. Each slot has a size of 32 bytes. 32 bytes. There are some differences how you are storing static values and dynamic values for arrays and the mappings. Okay, because you have a static values. What I mean by that, that's values that can be, for example, 10, 12, that can be true, and so on. So you can imagine the value will be not changing, or it can change, but the size will not change of the byte array. But for example, when you have an array of the items, so storing an array of the items, you don't know how many items you will have eventually, because, for example, in a smart contract can have a functionality to increase the array size. For example, as we have funders, all the funders that are added into the contract are added into the array, so you can get a really a large array. So these items are so a little bit differently as the static values. Okay. Then also you have a mapping values. So you have something like objects where you have a key and the value pairs. Okay, and these ones are also stored differently. Okay, so all of this we'll be talking about in this lecture. Okay, but generally keep concept in mind that we have this byte array of slots, and the number of slots is 200. Is 2 on the power of 256 minus 1, and slot numbering starting from the number 0, and the total size of each slot is 32 bytes. Okay. With that said, we can inspect how these slots will be created for us. And also one more thing, guys, just to not forget. When the node is running its client, so when you're running client and there is a Ethereum virtual machine, the values are stored a little bit differently on the computer. Okay, that's a mental model. That's a mental model you should have, and that's the also specification of the storage. And the data and the storage are actually kept in the case of a GEF. Just to not confuse you enough, in a GEF there is a used level DB database, level DB, that's a database from Google, and the values in the level DB database are stored in the key value pairs. Okay, so you will access basically your key will be your slot, and the value, whatever it's kept in the slot. And for this, it's a used level DB, but you can keep it in mind that all of the slots you can access can go only from a 0 to 2 on the power of 256 and minus 1. And when you will access the slot that doesn't have any value, when you access the slot, you will get back 0. Okay, so you're not keeping this entire array anywhere, okay? You're not keeping the entire structure of on the power of 256 minus 1, because that would be too big. You are just keeping in a database the values you have stored, okay? Okay, we'll be recapitulating this still, so if you are not sure right now, you will understand it very soon. Okay, so with that said, let's inspect what sizes we have here. So I'll write here next to each item. I'll write the size of bytes, how many bytes this value will take. So for example, you int 8, it can take only 1 byte, right? Because that's 8 bits. So this can take maximum 1 byte. All right. This will be 2 bytes. Addresses has a size of 20 bytes. All right. Then we have booleans have a 1 byte. Okay, and the uint 64 will have 8 bytes. 8 times 8 is a 64, 8 bytes. Then we have a 256, that's 32 bytes. 32 bytes. Then we have here uint 8, again, we have a 1 byte. And then we have again 32 bytes. So how does it work? How it will be, you can imagine now the storage is that every slot can take maximum 32 bytes. So the EVM will pack the corresponding values into the slots. Okay, so here you have a 1 byte plus 2 is a 3 bytes, plus 20 is 23 bytes, then plus 1 is 24 bytes, and here you have in total 32 bytes. So this space here, will take in total 32 bytes. 32 bytes, and all these values will be stored. All values will be stored in slot 0. Okay, you have reached the maximum of this. You are packing here 32 bytes. You have exactly here 32 bytes. These values taking 32 bytes. So this will be packed in the second slot. So it will be slot 1. Okay, slot 1. Here you have exactly 1 byte. But here you have a 32 bytes. So this will be also stored in the separate slot. Okay, it will be slot 2, because you see here the next item here has a 32 bytes, so you cannot pack 1 byte and 32 bytes into 32 bytes together. So this, unfortunately, this has to be in a slot 2 alone, and this has to be in a slot 3. So now you can see also ordering of your items matters, because it would be better if I would store it like this. For example, all right, this way this would be slot 2, and this would be slot 3. But also the next items, if I would have here multiple uints, this would be also in a slot 3, if it would be lower than 32 bytes. So you can see the ordering also matters how you will order your items, and therefore when you will deploy your contract on the network, you also will have a lower gas consumption. Okay, you will spend less gas for deployment of your contract, where you will order your data like this. So you need to also keep this in mind that ordering matters. But let's keep it unordered as I had it before, like this. Okay, so that's how the slot will be distributed, and now we can test it out. First, we need to migrate our contract. So I'll create a new migration. Number 3 underscore storage migration.js. I'll copy my faucet migration, copy it and paste it here, and I will call it storage, simply storage. And here will be storage. Okay, and deploy storage. Perfect. That should do it. Okay, let's verify everything, please. And let's deploy this contract. So I will go here, terminal. Okay, and we'll get here truffle migrate -- reset, and we'll try to access the storage items, and you will see how they are packed together. Okay, after this will be deployed, we will check our smart contract. So let's open your Ganache, go to your contracts, and you should have your storage. For some reason, I have 2 of them for. Okay, maybe I have specified in the previous lecture something, and this is created. Okay, never mind this. Let's go to our storage here, our actual contract, and here you have all these values, right? So you have a 7, 10, your address, boolean true, 15, 128, 28, 315, and so on. Actually, that's not your values, right? We have specified here 789 or something like this. But if you will copy it, actually, you will copy it like this. You will get a hexadecimal representation of the value. Actually, I was expecting to see here hexadecimal version of the value, and I don't see it. Or maybe, let me see, I will verify it. Hexadecimal to decimal, this number convert. Yeah, okay, that's the hexadecimal version. You see, that's the 789 that we have here specified. Perfect. Okay, that's cleared out now. Okay, now we have these values, and we can access them in the storage with the code. Okay, so how they are packed together? Let's inspect this. Let me go here in a terminal, and let's run here Truffle console. We will create an instance of our storage contract, and we'll try to access these items. Okay, so let's write here const instance await and storage dot deployed. All right. Now we have an instance, and actually, you don't need to create an instance at all. You can just use Web3 to access your storage, but I am just doing it automatically because almost every time we are running Truffle console, we are getting instance. But never mind this, okay? So you don't need to create actually instance. What you need to access here will be web3.eth, and the function get storage at like this, and you need to specify here address of your storage of your contract, and then the slot number. So we'll access the slot at the index of 0. Okay. So let's go to Ganache and let's get here address of your contract because we need it. Okay. So we are accessing the storage of a contract this at the index of 0. Let's press enter, and you will see that you will get here this item, this slot on the index of 0 hexadecimal format. Let's copy it and let's paste it here under this so we can inspect its values. Let's start from the right to the left. As the first value here on the right here is a 1 byte. There's exactly 1 byte. It's a value 7. So that's where the 7 is stored. Okay, so value 7. Then you have here 16. That's a 2 bytes. That's the 1 byte, 2 bytes. That's this. So that's the value 10 because A has in hexadecimal value 10. That's the value 10. Then we have here address D1 and finishing and starting the 64. That should be. Let me see where it's. I will just copy the seat. Okay, so that's the entire address here. Okay, so that's your stored address in the storage. The entire 20 bytes. Okay, then we have an address. Then we have here 1 byte of boolean of true. So that should be it here. So that's 1 byte. 0, 1 is 1 byte for a true value. It's here. Then we have here last value 0f, and f has a value of 15 in hexadecimal. So that's the last value 0f and 0x. So just marking that is hexadecimal string. Okay, so you can see all of the values are packed in one slot at the slot 0. When I want to access slot 1, the same thing. I'll just access here slot at index of 1. C8, C8 is a 200 exactly. When you will transform it from a hexadecimal to decimal, C8 will be value you are looking for, 200. Okay? Then you have here slot 2, so we can try access slot 2. Okay, so slot 2. Okay, 0x28. 0x28 is exactly 40. Okay, then you have here 789, so that will be slot 3. Okay, and that's a 0x0315, and that's exactly the value. You can see the value we are keeping in the storage in hexadecimal. So that's the values, how you are keeping them in the storage, and they are persisted and they can be accessed on the blockchain in form of this block array that I have draw here. Okay, and every client is keeping it can keep a different database. In the case of a GEF, which is a client for connecting to Ethereum network, the implementation is LevelDB, and actual data are stored on each node computer in the format with the help of LevelDB database, where the key is the slot number. Okay, guys, I will be talking about the storage in the next few lectures. So let's get a break here and let's continue in the next lecture. Cheers.